Today we're going to be talking about angles of triangles. I think most of us at this point are pretty familiar with the fact that all the angles of a triangle sum to be 180 degrees, but that might be one of the only properties that we're really familiar with. So we're going to look at some new theorems and some corollaries to those theorems and figure out how we might look at some missing angles, also the difference between interior and exterior angles, and how everything is related. So if you'll take a look at this list here, we have a couple of theorems, which remember are rules that we have proven to be true so then we can use them. The triangle angle sum theorem says the sum of the interior angles in a triangle is 180 degrees. The third angle theorem says if two angles of one triangle are congruent to two angles of another triangle, then the third angles of the triangle have to be congruent. Those two we're pretty familiar with, and especially that second one, it just makes logical sense. Now the next three are corollaries, which are things that are as a result of those theorems. The first one says that each angle in an equiangular triangle is 60 degrees. Obviously, if I know that the sum is 180 degrees, and they're equiangular, meaning they have equal angles, then the triangle is going to have individual measures of 60 degrees. Corollary 2 says that acute angles in a right triangle are complementary. Let's think about what that means. A right triangle has to be 90 degrees in the corner, and then complementary means that they add to 90 degrees. So if my total is 180, and that's equal to one angle that's 90 degrees, plus the measure of angle 1 and the measure of angle 2, whatever those measures are, then these two are automatically going to add up to be 90 degrees, because that's how much I have left over. So those two angles would be complementary. This last one says there can be at most one right or obtuse angle in a triangle. Again, if I have a 90-degree angle, I have to have two acute angles because I only have 90 degrees left over. If I have anything larger than 90 degrees that's obtuse, then obviously those other two acute angles would have to be acute as well. Okay. This next one talks about exterior angles. It says the measure of the exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. And that's labeled here on the figure for you in case you're not familiar with what that means. So remote interior are the two interior angles that are not adjacent, the non-adjacent interior angles. So for instance, in this one, the measure of angle ACD is equal to the measure of angle A plus the measure of angle B. So if I wanted to find that measure in this example, then I would take x plus 80 and set it equal to 3x minus 22. And finally, you would get the measure of angle A is equal to x, and so x is 51 degrees. You could plug that back in to find any of the others if it was asking you for the exterior angle as well. Here, we are asked to find the missing angles in these two figures. So the first one, we have 59 and 57. If I know that these all three have to add up to be 180 degrees, I'm going to add 59 plus 57 plus the measure of angle 1 and set it equal to 180. When I subtract those two angles out, I have 64 degrees left over. So that means that the measure of angle 1 is 64. Here, in this next example, I have 23 and 32. That means that this angle down here is going to have to be 180 minus 32 minus 23, okay, which is equal to a 125 degree angle. This one here is vertical to it. So this one's also 125 degrees. Now the measure of angle 2 is adjacent and supplementary. It's a linear pair to either of these 125 degree angles. So that means I take 180 and subtract 125 to give me my measure of 55 degrees for angle 2. The measure of angle 3 is on the inside here. I already know that I have 22 and 125. If I add those two things together, I have 147 degrees accounted for already. So if I take 180 minus 147, then that leaves me with 33 degrees left over. And last but not least, we're looking at angle 4, which is a linear pair with angle 3. So if angle 3 is 33, I take 180, subtract 33, which gives me 147 degrees. You can also use the remote interior angles here to find this exterior angle. So 125 plus 22 should give me that 147 as well. So we have another set to find the missing angles with. This time we have some different labels here. 122 is the top one, and you'll notice that the measure of angle 1 and the measure of angle 2 are supposed to be the same. So if I take 180 and I subtract 122 from it, then I want to divide by 2 to get the measure of angle 1, which would be 29 degrees, and then the measure of angle 2 would be the same thing, so also 29 degrees. In this one, 3 and 4 are vertical angles, so I can take 87 plus 27 and subtract that from 180. And that's going to leave me with 66 degrees left over for the measure of angle 3, which means that the measure of angle 4 is also 66 degrees. And once I know that, I can take 180, subtract 60, and subtract 66 to get the measure of angle 5, which should be 54 degrees. So I would like for you all on these last examples to work them on your own and then come back and check your answers. Alright, so with the measure of angle 1, we've got 75 plus 40. We subtract that from 180. There's 65 degrees left over. 1 and 2 are supplementary, so 180 minus 65 gives me 115. 1 and 3 are vertical, so those should be the same measure, which makes that 65. And then over here, we have 110 and angle 4 are supplementary, so angle 4 should be 70 degrees. And then the measure of angle 5, once I have 70 and 65 already accounted for, there's 45 degrees left over. We're going to move on now to your next set of notes, which says the triangle sum theorem at the top. This just gives you a couple of extra examples that also include those remote interior angles and exterior angles as well. So in example A, we know that 1 and 2 are vertical. I can find the measure of angle 1 having these two given to me. So 85 plus 40, subtract that from 180, I get 55 left over. Measure of 2 is 55 because it's vertical, and then I can take these two 55s and subtract from 180 to get 70 for the measure of angle 3. Now in this next one, I have these two angles here, which are my remote interior angles for angle 1. So I add 70 and 55, which gives me 125 for the measure of angle 1. The measure of angle 2 is vertical, so you've got 55 degrees here. Then with this one, I have 150 that's supposed to be equal to the measure of angle 2 plus the measure of angle 3. So if I know that the measure of angle 2 is 55, then the measure of angle 3 must be 150 minus 55. So then I know that it's 95 degrees. Here we have the same thing. Add your 80 and 60 to give you 140. That's the measure of angle 1. These two angles are supplementary, so the measure of angle 2 is 40. Then I know from this one that the measure of angle 4 must be 75 degrees. So I can add these two things together and get 115 for the measure of angle 5. Now the only thing that we're missing is angle 3. So if I come back over here, I've got 4 is 75. This one here should also be 75 since it's supplementary with 105. So the measure of angle 2 plus the measure of angle 3 should be 105. 2 was 40 degrees, 3 was 65 to give me 105. You can also take 105 and subtract this that you already have, the 40, to give you the 65 that's left over, because these two should add together to give you that. Lastly, we have a right triangle here, and there's a right angle up here. So if I know that this is 90 over here as well, then I have 90 and 63 already accounted for. So the measure of angle 1 is going to be 27 degrees. If that's true, then this angle up here has to be 63. So the measure of angle 2 would also be 27 degrees. So it's just a matter of remembering that they all sum to 180 and looking at the relationships between them.